Hey guys, Miss Watson here for your homework review on the 11.1 to 11.3 worksheet. Thank you to the 20 people that filled this out. I'm just going to scroll down here. We're looking pretty good, still pretty good until we get to 10. So we'll do 10 and 11, and then we actually look pretty good for the rest of these. Okay, and be sure to check out the entire key that I do post um, with today's post. Okay, we have some questions as well. So I'll do my best to get through those questions. All right, here we go. So the first one was 10. All right, so one of the tricky things about this one is um, what are the total possible outcomes? So this goes back to day one of probability. Total possible outcomes. This is our fundamental counting theorem. If you're spinning it two times, right? So on the first spin, um, there's four possible outcomes, right? A one, two, a three, a four. On the second spin, there's another four. So our total possible is just 4 times 4, which is 16. So remember, that's from day one, our fundamental counting principle. That was like Scarlett has 10 pairs of pants and 12 pairs of tops. What's the number of possible outcomes? You would just multiply the two. Okay, so what is the theoretical probability of getting a sum of 4? Well, now we need to figure out how many times can we get a sum of 4. So in order to get a sum of 4, on our first spin, we can get a 1, a 2, a 3. Notice I'm not putting 4 because um, we're not going to get a sum of 4 if we spin a 4 on either of the spins, right? So over here, to get a sum of 4, if we spun a 1 first, we'd have to get a 3. Spun a 2 first, we'd have to get a 2. Spun a 3 first, we'd have to get a 1. So total number of outcomes that have a sum of 4 is 3. So that means our probability is just going to be, so probability sum 4 is 3 over 16. And as a percentage, 18.8%. Okay, let's look at the next one. What is the theoretical probability of getting a sum whose multiple of 3? Okay, so remember, we still have total possible 16. That hasn't changed. So let's do multiple of 3. Um, sum multiple of 3. So let's just think about this, right? Our multiples of 3. If we, so I'm going to do it this way again. So let's just say we roll a 1 on the first spin. I'm sorry, I keep saying roll. We spin a 1 on the first spin. Um, what else? What would we have to spin on the second spin to get a multiple of 3? If we spin a 1, the sum would be 2. That's not a multiple of 3. We spin a 2, the sum is 3. That's a multiple of 3. We spin a 3, the sum would be 4, not a multiple. We spin a 4, the sum would be 5, not a multiple. Okay? So it's the only possible multiple if we spin a 1 on the first spin. Let's go to the next one, 2. Well, if we spin a 1, it works. But also, if we spin a 2 and then a 4, that's 6. So that's also a multiple, right? So if you're still not quite following, look at what the sum is. Okay? 3 would be, we can't spin a 0, so that's not possible. So 1 doesn't work, 2 doesn't work, 3 works because we get 6. 4 doesn't work because that would be 7. And then let's do 4. 1 would be 5, 2 would be 6, 3 would be 7, 4 would be 8. So how many are there? There's 5. So that means that our probability of sum multiple 3 is going to be 5 over 16, which is approximately 31.3%. Okay. All right, let's move to the next one. This is the geometric probability. Um, okay, so we have this diagram. It says rectangular yard shows a circular pool and a triangular garden. A ball from an adjacent golf course lands at a random point in the yard. Find the probability. So the ball lands in the pool. So first thing I want you to think of is the probability. So in pool, is going to be, so we need to know the area of the pool over the area of the entire yard, right? The entire rectangle. So the area of the pool, so area of a circle is pi r squared. So it's going to be pi radius of 12, so 12 squared. The area of the yard, well, it's just a rectangle. So length times width, so 100 times 50. And if you work that out, it's 144 pi divided by 100 times 50. And you get 0.09, which that means as a percentage is going to be about 9%. Okay, so remember, guys, geometric probability is just the area of where you want it to be over the area of the entire thing. All right, so let's do the next one. So now it's in the garden or the pool. So now let's remember an or statement. So probability of garden or pool is going to be probability that lands in the garden plus the probability it lands, plus the probability it lands in the pool less the probability it lands in the garden and the pool. Okay, so remember you have to take away the probability that it can happen in both. But that's mutually exclusive, so that's going to end up being 0. Okay, well, it turns out we already have the probability it lands in the pool, right? That's 9%. So we just got to find the probability it lands in the garden. So this, I'm going to do over here, would be the area of the garden over the area of the yard. And we know that the garden is the triangular portion, right? And we know that this is a rectangle, so this is a right angle. So the area of the garden is going to be 1/2 base times height, so 8 times 6. The area of the yard, we already know, is 100 times 50. Okay, now, so that's actually this. Now, the probability of it lands in the pool, we just figured that out. That is 9%. And then the probability, subtract the probability that it lands in both. Well, it can't land in both, right? Because the pool and the garden don't overlap. So this is going to be -0, right? And that's because these are mutually exclusive events. So I wanted to show it so that you remember that you have to subtract it. But if the events are mutually exclusive, then there's nothing to subtract because you're subtracting 0. Okay, so let's work this out. Let me plug this in. And here I'm going to change it to percentage. I get 0.48% plus 9%. So my final answer is going to be 9.48%. Okay. I think that was it to go over. I am going to post the key. Let me look down at these questions. I forgot to do that the other day. All right, 10 and 11. We did. You know what? Let's do 19. Area of a circle, pi r squared. All right. For problem number 1, we have to write it out and show our work, or can we just use a calculator? You're going to be using a calculator, right? The only problem is if you don't show work, then I can't give you any partial credit. So just remember that if you get it correct on a problem like number 1, I recognize that that's a calculator problem. You don't necessarily have to show work. So if you get it correct, then you're good. But if you get it wrong and you don't show work, I can't give you partial credit. All right, number 6, why would it be permutations and not combination? Let me look at number 6. How many different 5-letter codes can you make from the letters in the word cipher. The reason why this is permutations is that order matters because it's how many different 5-letter codes. So um, that kind of means like, is the letter C in the first spot, or is it the second spot? Is it in the third spot? Is it in the fourth spot? Is it the fifth spot, etc. And it does matter because you don't want any repeats, right? Because it's how many different 5-letter codes. All right. What else do we have down here? So we got this. We got this. Is it okay to round your answers? Should be exact. I'm gonna know if you guys are rounding. Generally speaking, you can see I've put everything almost in decimal format, and I round to the nearest tenth as a percentage format, and I round to the nearest tenth. So I take the fraction, I convert it to a decimal, and then I take that decimal, multiply by 100 to get the percentage, and then I usually round to the nearest tenth. If you round to the hundredth, I'm going to know what you're doing. Okay. 6 I just went over, 10 and 11 went over. So the only one I need to look at is 7b and 19. 7b says, is it true or false? This one is going to be false. And here's a counter example. Let's do 4 factorial over 2 factorial. So a is 4, b is 2. And let's see, that equals 12 versus 4 over 2, the quantity factorial, which is just 2 factorial. So that just equals 2, right? And 12 does not equal 2. So that's why this one's false. Okay, and then let's look at 19. I'm just going to, let me see here, because okay, so I'm just going to look at A on this because I think they're pretty similar. It says that you have a drawer with 5 pairs of socks, 3 pairs of black socks, 1 pair of red socks. You choose 1 pair of socks at random each morning, starting on Monday. You do not put the socks you choose back in the drawer. Find the probability. So first thing is always how many total socks, or total pairs, whatever. We have 5 plus 3 plus 1, so it's 9. Okay, so what's probability? You select black on Monday and white on Tuesday. So we need to find the probability of each. So the probability of black on Monday. So Monday's your first day. So on Monday, you still have a total of 9 pairs. How many of those are black? 3 of them. Probability of white on Tuesday. So now you don't have 9 pairs because you took one out on Monday and you didn't put it back. So now you only have 8. And how many of those would be white? Well, you didn't take white on Monday. So you still have 5 white ones left. So then you take this and you say the probability is going to be, you multiply them. So it would be the probability of B on Monday. Oh, let me just write it this way. B on Monday times probability of white on Tuesday. So it would be 3 over 9 times 5 over 8. Work that out. You should get 15 over 72, which is the percentage, is 20.8%. Okay, I'm not going to do B. I'm going to post the key, but B is very similar to A. All right, guys, I hope that was helpful. Thanks and good luck on the quiz today.